So this is a graphical view we'll do of the proton-proton chain, and you can get yourself a copy of this graphic on Canvas if you want to follow along. I'm not going to write too much on it, but it's definitely a nice graphical version of the reactions that I wrote, which can be on the previous video, which can be a bit hard to follow. So let's just get right into it then. So the first thing that goes on here is that this side over here and this side over here are the same thing. Okay, we'll just do one, but you can see they look exactly the same. But the point of this graphic is that these reactions are going on simultaneously all over the sun. It isn't just one reaction going on, so it looks like this. Okay, so what we said in the list of reactions I gave you earlier is here's the hydrogen and the hydrogen both coming together, and normally they wouldn't like to come together because they're positively charged, but it's so hot on the sun, they're moving so fast that they can so-called fuse together, and that's you're seeing right here. And when they do fuse together, here's that positron coming out, which is a positive sign, and this is that neutrino coming out. So I know it looks like a symbol V, but it's actually the Greek letter nu for neutrino. Okay, and there you go. And then what happens next, of course, as we said, well, the same thing happens over here too, right? Exactly the same reaction. Okay, so going down, the next thing that happens is that another hydrogen that's floating around combines with this heavy hydrogen over here. Remember, this is the deuterium right here. This is the deuterium. Why is it deuterium? Because there's this one proton right here, and there's that neutron right there. So it's a tad bit heavier. Again, if you look on the periodic chart, the most abundant hydrogen that we know of doesn't have that neutron in it. This one does, so it's a heavy hydrogen. And what happens is they come together, and this is the Greek letter gamma, so there's that gamma ray that comes out. As we said, the gamma ray that comes out. And now you have this sort of form of helium here, which isn't the one we're most familiar with here, because it's made out of a proton and a neutron in there, just one neutron. And that's sort of this helium isotope. Not the most common one, so this is not the one that is on the periodic chart. Like the periodic chart does not have a 3 there next to helium, it has a 2 for the number of nucleons. Okay, so and going just back up a bit here, you can see that, again, it's the same reaction going on. It comes down, there's the positron, the neutrino, there's the deuterium, combines with another hydrogen, there's the gamma ray coming out. But the point is that once you get down to this line here in the reaction here, there begins to be an abundance of this strange form of helium floating around in the sun. This helium with the 3 nucleons, the 2 protons and 1 neutron, 2 protons and 1 neutron. Now, those two things can come together here and here, and what they cause to form ultimately is these 2 protons are going to come back out again. There's a proton there and a proton there. And what comes down here, this is the helium on the periodic chart. So the helium that has the 2 around it on the periodic chart, this is the one that we're used to seeing right here. So remember the 2, at least on the periodic chart I showed you earlier, this is the number of protons, 2, 1, 2, not the total number of nucleons. There are 4 nucleons because if you look, of course, you can see here, there's 1 proton, 2 protons, 1 neutron, and another neutron. That's 4 total, but the number on the top of this box here just refers to the number of protons. So I think I might have said that wrong up here. So this should be labeled up here. This should actually be labeled the helium-2. I do agree it does have the 2 protons, but it also has that other neutron hanging around. So in either case, this is just not the one that is in the periodic chart. It is a form of helium, but it's an isotope that's not in the periodic chart. Okay, so that's it for the proton-proton chain. Again, hopefully you can see what happens here. And again, on that last step, just to match up the colors with the purple here, remember these hydrogen, these protons that went in are also what come out. And so these 2 protons that come out, let's just say, are ready to go again. And by go again means they can come together and start the chain reaction over again. And that's, of course, where the word chain comes from in all this business here. Okay, there you go. Graphical view of the proton-proton chain reaction.